In one beaker called A, we put 1.5 grams of sodium iodate dissolved in 10 milliliters of sulfuric acid at 1 mole per liter and 100 milliliters of distilled water.
In one beaker called B, we put 1 gram of malonic acid and 1.5 grams of sulfate manganese dissolved in 100 milliliters of distilled water. Then we add 10 milliliters of soluble starch at 1%.
We mix the solution A and B in a beaker. Then we add 50 milliliters of hydrogen peroxide at 10%.
We stir it gently using a magnetic stirrer.
Within a few minutes, the colorless solution turns yellow with slow changes in the intensity of color. Bubbles of oxygen appear too.
Suddenly, the solution turns dark blue.
After a little while, the solution returns colorless and shows periodic changes, both gradual and sudden. The reaction oscillates for almost 10 minutes.
This experiment demonstrates that a complex combination of slow and fast reactions are taking place simultaneously.
The 3 colors observed are a result of an increase in the concentrations of iodine I2, yellow, starch iodine complex, dark blue, and iodide ion I-, colorless, in order of appearance.
In one beaker called A, we put 1 gram of potassium hydroxide dissolved in 20 milliliters of distilled water. In one beaker called B, we put 1.26 grams of glucose dissolved in 20 milliliters of distilled water.
In one beaker called C, we prepared a solution made of 25 milliliters of methanol and 0.2 grams of benzoene.
We mix the solution A and B in an Erlenmeyer flask. Then we add solution C and some indigo carmine until we have a strong color.
We seal the flask with a stopper. After a gentle shake, the solution changes color from yellow to red. After a more vigorous shake, it turns from red to green.
Once left alone, the mixture will return to yellow and the process may be repeated.
We can see different colors because we have successive reactions which occur.
First, the oxygen in the air is dissolved when shaken, thus making the indigo carmine green. It reacts slowly with the glucose too.
Therefore, the concentration of oxygen is decreasing and the indigo carmine returns to its first color, yellow. The intermediate color, red, is due to the benzoene.